Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a new topic regarding Rayleigh method of dimensional analysis. In our last lecture also, we discussed regarding the dimensional analysis and the method of dimensional analysis. In the method of dimensional analysis, Rayleigh method is one of them. And in the Rayleigh method, actually, we have discussed in our last video lecture, but still I'll give us some hint about this. The Rayleigh method actually, it is used to determine the expression for any kind of variables where that variables should depend upon like 3 to 4 variables only, not more than that. So in the last lecture, we have solved a problem where 3 variables are there. Okay, and now we'll solve or we'll find an expression for some variables where 4 variables will be present here. So in this problem, actually, I have taken an expression where 4 variables are there. Now, if you see the question, find an expression. Here we need to find out the expression, and that is for the drag force. And the drag force on a smooth sphere of diameter. So diameter moving with a uniform velocity v in a fluid of density rho and a dynamic viscosity of mu. So in this expression, what is given? It is given that we need to find out an expression for drag force, and the drag force is depend upon some variables, that is dv, rho and mu. So for this we can write, that is, let's suppose if you want to solve this, so write down the solution for this, and here we can write the drag force F is a function of, or is a dependent on these are the variables. So for this we can write, first step we can write like depends upon d and v, and here we can write rho and mu. These are the some variables are there, or you can say f is a function of, or you can write like this, f is a function of, like this we also you can write. Now same thing I can write in next expression, like f equal to in terms of some constant, let's put it here, and some variables, and some arbitraries we need to keep it, actually power arbitraries, that is d to the power a and v to the power b and rho to the power c and mu to the power d. So these are some arbitrary powers, and k is the constant here, non-dimensional factor we can say also. And now here we need to find out the expression, the dimensional expression for both sides actually. Then we need to compare all these dimensional values, and after that we'll find out the expression. So what I mean to say here, suppose this is the force in one side, so force is in the left hand side is there, so this is left hand side, and this all the terms are in the right hand side. So we need to find out the dimensional expression for the right hand side and left hand side both. Now here if you see, first one, let's find out the dimensional analysis. The dimensional or dimension analysis also you can write, dimension analysis for left hand side. So you can write F equal to, we know that force unit is Newton, and this Newton we can write in terms of kg meter per second square. Actually this one also you can write F equal to ma also you can write, and mass into acceleration there also you can identify by that. And here simply we can just write down the if you know the unit for that, it will be easy for us also. Now in kg we can write, this is kg means mass. See, dimensional analysis we need to consider the fundamental dimensions. So fundamental dimensions are, we know that m and l and t. So these are the fundamental dimensions or fixed dimensions we can say. Okay, so these are the things, these 3 things we need to consider for putting or highlighting any kind of dimensions here. Now mass is kg, so m, and meter, that means length, so m, l, and this is second square, that is time square, so that is t square. So when it is denominator, let take it to the numerator, so that will be -2. So this is the dimension for the force. Okay, now similarly we need to find out the dimension, we need to do the dimension analysis for the right hand side. So right hand side one by one, because we have total 4 terms are there, so we need to find out one by one. Let's find out first one, d. So d is the diameter. So diameter means we need to take that is one value of length, we can say. So that one we can write only in terms of L. So dimension analysis is L. And similarly, next one is velocity. Velocity, we can write this is distance by time. So distance by time means we can write this is, suppose, write down here, this is distance per time. So distance also same thing as I told, that we need to consider L by T. And this one, if you put in terms of expressions, this is L and T to the power minus 1. Similarly, velocity, next is density. So density is, we know that this is mass by volume. This is mass by volume. And this mass by volume we can write in terms of unit, if you write, that is kg per meter cube. And similarly we can write this is kg is, this is mass, and meter cube we can write this is length. So length q. So that means in terms of this dimensional, you can put m L to the power minus 3. So this is about density. And the last one is viscosity. So viscosity, actually we have already derived this expression of a dimension in our first lecture. So that one you can follow, or just I'll give a hint of this, that this expression came from the Newton's law of viscosity. There we know the expression is tau equal to mu into du by dy. So that mu equal to, we can write tau divided by du by dy. So tau is nothing but shear stress. So shear stress you can write it is force by area. So force by area again divided by this one, you can see this is velocity by distance. Again, if you can write this, this is force, as I told you, mass into acceleration by area. And here velocity distance by time, that is L by T. Again dy is the distance, so that one we can write only L. By solving all these things, finally, actually I'll write final expression. If you want more details regarding, you can go our previous videos, you can see the simple only force, mass into acceleration, or directly you can take it from the this previous expression what we have derived here, m equal to, and area, we know that expression area is a square, a, that means area square, that means we can write L square, length into length. Similarly velocity, and this is also distance. So finally what we can write here, the expression for this viscosity is, we can write m and L to the power minus 1 and T to the power minus 1 after solving all this numerator and denominator part. So now if you see here, all the expressions we have identified. So let put a line here. Now we need to equate all these equations, all these powers we need to equate. So first let write down the expression what we got here. So here we can write, this is in the right hand side, what left hand side, what is there, m L and T to the power minus 2. Okay, this equal to, we can write k into, k is a non-dimensional number, we can put the value of just we can write put k, or we can write m to the power 0, L to the power 0, T to the power 0 also we can write, but there is no value for that. So let k into, and first one is d to the power a. So d, what is the if you see d, this one, this is the dimensional expression. So we need to put the value of d here, that is nothing but L bracket and to the power factor, power arbitrary a. Similarly, next is velocity, v to the power b. So actually here this is the expression 1 we can give. This one expression 1 we can give, and we can put all this value in the equation 1. That will be more better understanding here. So next L I have given in on behalf of d. Next is velocity. Velocity is again what is the dimensional value here? We just put the value of velocity here. So that means again square bracket, and dimension analysis for the velocity L T to the power minus 1 bracket close, and the power factor b. Similarly, what is the next one? Density to the power c. So density expression we got there, L to the power L to the power minus 3 and m is there, okay, and to the power c. Now finally mu to the power d, that means viscosity to the power d is there. So viscosity expression m minus 1 and t to the power minus 1 whole bracket to the power t. So this is all about the expressions. Now we need to compare this right hand side and left hand side all expressions. So now by equating this right hand side and left hand side variables, we can see what is the power of m. Now write down the power of m equal to, we can write in the right hand side these are the values and left hand side these values. So power of m, we can in the left hand side what is their power 1, and left hand side if you see L to the power m, first one m, there is no m, here m is there, m to the power 1 c. So 1 into c, that one you can write c. Similarly here 1 and d, so c plus we can write this is d, okay. Similarly next we need to write power of L. So power of L also, let's see here in this side 1 is there, and this is left hand side, and right hand side what is there? Right hand side we have L to the power a. So that means we need to write a, and this is L to the power b. So 1 into b, 1b, and here L is minus 3, here c. So that means we need to write minus 3 into c. And finally here minus 1 into d. So this is minus d. So this is the expression or power of L in both sides. Similarly, we need to write power of mlt. So t is there. Again t, if you see in the left hand side minus 2, and in the right hand side what is the value of t? Minus 1 into b. So this one we can write minus b, and t in the last term is there minus 1 into d. So this is minus d. So this is the comparison between the left hand side and right hand side, all these powers. Now if you see here, a total how many unknowns are there? We have total 4 unknowns are there. We can say let's write here, total we have 4 unknown are there, correct? And but here how many equations are there? We have 3 equations are there. What are the 3 equations? These are 3 equations, 1, 2 and 3. These are 3 equations are there, but 4 unknown a, b, c, d are there. Now so that it is not possible to find out the values of a, b, c, d from these 3 equations, okay. So what we'll do here, that fourth expression, that means all these 3 expressions, which is the most important, we need to identify. So what are the variables are given? Now d, diameter, velocity, density and viscosity. Now here if you see the fourth variable is d, or you can the viscosity variable, and which is most important, and because viscosity is the vital role playing in the drag force, okay, and remaining are all all importance is there in this drag force, but which is having the most vital role in the drag force? So viscosity. So viscosity term, let's consider viscosity term, and viscosity term was represented with the power factor of d. So what we will do, so all this ABC term, all this ABC part, let express in terms of d, so that the power viscosity what is given. So what I told you, just you need to find out which is the most important parameter is there, or which is the most important variable is there. Let consider that one and go for that power. What is the power is there? So that is important is here what I have taken viscosity. Suppose what is the power of this is, and that is d is given. So let convert all these terms in terms of d, okay, then we can easily find out actually. Now so if you see, so from this expression I can identify first from the first expression, this one, from this expression I can convert this value in terms of d. That means let's find out the value of c. So let's find out the value of c in terms of d. So 1 minus d, okay. Similarly in the second expression, let keep the value. Here in the second expression, we cannot find out the value because it is 3 or 4 unknowns are there, so difficult. Let's come back to the third one here. If you see this one, B and D is there, B and D are there. So let's keep the value here. What is the value here? Let's suppose this is B minus D is there. Let's keep B one side because one more unknown will be there, that is D, so that will keep in the right hand side. So B equal to, we can write 2 minus D. Just I'll take this B this side in the left hand side, so that will be positive, and 2 the value, they take it to right hand side, so that it will be also positive. And as usual, that minus negative sign is there for the D, that will be as usual, it will be there. Similarly, if you go for the second expression, this one, second expression, here we can write the value. Suppose let consider A one side and remaining terms let keep it to other side. That means A equal to 1 minus B plus 3C plus D, because see A like BC is there, remaining one more is there A, because we need to keep all the D one side, and so that we can find out the expression. Now here put the value of this C and B here actually. So by putting the value of C and B, we can get 1 minus B value what? B value 2 minus D. So put the value of 2 minus of D. So minus minus plus will be there. So 2 plus D. Similarly plus 3C. C value what? 1 minus D. So we can write this is 3 and this is minus 3D will be there. Okay. And finally the value of this is D. Now if you solve this value, finally if you see 1 minus this is 3 plus 1 4 minus 2 2. So you can write 2 and D 2D, this is minus 3D is there, so minus 3D plus 2D, so we'll get minus D. So this is the value of A. So now if you see, we got all this value, okay, A, B, C, D value, not D, A, B, C value, we got it in this way, we got the value. This is B, C and this is A. Now we need to substitute the value where? Now where the equation 1, which is the equation 1 in the starting, this one, I've given the equation 1, this one. Now put all this value in the equation 1. After putting the value in the equation 1, we can find out the expression. That is our ultimate goal. So what is the equation is there? F equal to, we can write K into first one D to the power A. So A value what? A value is, we can write A value is 2 minus D, and next is V to the power B. What is the V value? 2 minus D. Again 2 minus D. And similarly, what is the value of rho to the power C equal to 1 minus D. So rho to the power 1 minus D. And finally mu to the power D. So what is the value of D here? D as usual, same, keep it D, because D we have not identified, only we just converted all the value in terms of D, so that will all these power factors will be only same powers will be there. So now here we need to split all these things one by one. We can do it, like we can write this K into D to the power 2. Let's write in terms of this D to the power 2, V to the power 2, and rho to the power 1, that is rho, and here we can write D to the power minus D. This one, this power factor we have splitted like this, D to the power D and V to the power minus D, again rho to the power minus D and mu to the power D, and bracket close. Now if you see this term, I can again write this one in terms of, like, you know, K rho, and this is V square, and this is D square, and again if you see here the bracket, I can write in terms of mu, positive D is there, so let's write mu, and mu to the power D is there, so I'll take the common of D, and remaining these negatives values are there. What are the negatives of minus term is there, so that one we can keep it to down one, that is rho, and this is V, and this is D, whole bracket. Now D we can write this, and finally what the expression we can write here, the expression for the drag force F equal to, we can write K into rho V square, and this is D square, and this to the power D term is there. That one we can convert in terms of a value of phi, and we can write mu divided by rho V D. Okay, we can convert this in this way, or else we can keep in this way also. So both are correct, and the value of K will be given because this is a constant of proportionality, or you can say a constant of dimensional factor, so non-dimensional factor. So that value will be sometimes given, or we can consider sometimes 1 also, K value. So I hope you understand. Actually, this problem actually where 4 variables are there. In our last video lecture already we have discussed regarding the 3 variables. So when 4 variables but 3 equations, see, 4 unknowns but we have 3 equations. So in this case, how to identify the expression, how to calculate the expression for the any kind of variables. So this is the method to calculate. So I hope you understand the method of calculation in the dimension analysis. Still, if you are having doubt regarding this or query regarding this, you can give a comment on the comment box. Thank you all.